Okay, welcome back. So in this part, we're going to start with constructing our mesh, so our cloth mesh, so the mesh that's going to represent our cloth, and then we're going to move on to rendering it. So we have our cloth mesh here that you can find here on your solution in headers. It's called clothmesh.hpp, and it's just a struct. We're not going to have a CPP file here because it's just a struct. So it contains this texture load thing that we're not going to concern ourselves with because it doesn't really matter right now. So the first thing we want is to figure out exactly how we're going to store information about our vertices that are going to make up our mesh. So for that, we need two things. We need each vertex to contain basically its position, so where it is in the world, and its texture coordinates. So let's make a new struct called simple vertex, and I'm calling it simple vertex because I already have a vertex for rendering proper models and meshes somewhere, so not to confuse anything. So just a simple struct, and what we're going to do with this is we're going to contain our position. So it's going to be a glm vec3 that I'm going to call pause, and it's going to be a glm vec2 for the texture coordinates. I'm going to call it text coords. Okay, that's pretty simple. And I'm going to make a constructor just because it's nice practice. So simple vertex, glm3 pause, and glm vec2 text coords, and basically the constructor is not going to do anything. I'm just going to initialize or set them here. Okay, that's it. So this is what we're going to use to store our vertices. So we're going to be storing two things, position and text coordinates, nothing else. The next thing that we need is to figure out what our struct cloth mesh will contain. So what will it hold? What do we actually need for the mesh? So we're going to start with what we need for, we're not going to concern ourselves with the simulation right now. We're going to start with what we need to build the actual thing that we call cloth mesh. So obviously we will represent this with a set of vertices, and we're going to use the simple vertex struct. So we're going to say standard vectors. We're going to have a vector of these, simple vertex, and I'm going to call it vertices. Very, very simple. So for now, we just have vertices. Then we also need a set of... So let's think about how we're going to render this. We want to render this as triangles because we like rendering triangles. So we're going to need indices for this. So the way we're going to construct our cloth mesh is going to be like a grid. So imagine that you have a grid of vertices. Let's say that you have a square grid. So you have basically a resolution both on the width and the height that is the same, or both the width and the depth that is the same. So let's say that your resolution is that you have 4 vertices on the height, and 4 vertices on the width, and 4 vertices on the depth. And that's how we're going to create the actual mesh. Let's store these somewhere. So we're going to say float width. So it's a few floats that are going to be float, width, and height. And then we're going to store width step. So that's going to be the distance that we want between the vertices. And depth step. Again, the distance that we want on the depth. And we're going to save du and dv, which is the delta for the texture coordinates for u and for v. So that's a few floats that we're storing that we're going to need. And because we're going to be rendering this with OpenGL, let's store the classic unsigned int, our VAO, our VBO, and because we're using indices, our EBO. And let's store our grid resolution, which is going to be an assigned int. And let's store our texture ID as well, because, like I said, we want to texture it, so we need a texture ID to be stored somewhere. So this is going to be for rendering mainly, other than the grid res, which is not for rendering. So that we have the basic things that we need, but we don't. So let's not add anything else right now. The first thing we need to do is build a grid of vertices. So let's see how we do this. Let's make a constructor here. That's going to be cloth mesh. And I will set the constructor to have everything. So we need float width, float depth. It's going to have an unsigned int for, that's WP, which is basically to calculate the step for the width. And unsigned int, I'm going to call it DP for the depth step. And then the resolution, which is just going to be another unsigned int. Because I want to be able to select the texture from my textures folder, I'm actually going to set a standard string that's literally going to be the texture file. And I'm going to give it a default value of cloth texture.png, because why not? And then, so one thing, we're creating a grid for our cloth mesh that is going to be, imagine it in 3D, it's going to have, all vertices will have the same height. So it'll be like a flat floor. So we're going to be setting for every vertex the same height, and then we're going to be setting depth and width. So X and Y, or X and Z will be set, Y will be the same. So here I'm going to also pass another variable that's going to be float, and it's going to be the init height, so where it's actually going to be. And I'm going to set it to 2.0f because it's a good value. Okay. Before we move on to the inside of our constructor, let's set some of these properties. So let's say width, it's going to be width. Depth is obviously going to be depth. And our grid res is going to be grid res. Okay, so these are our default values that we're setting. Now, the next step is to write the inside of the constructor. So the first thing we're going to do, eventually, the first thing we're going to do is we're going to load a texture, but we don't really concern ourselves with that right now. So first, we need to calculate the vertices. What does it not like here? Oh, I named it height. Oops. Good. So first, we want to calculate the vertices. So I'm going to make a comment here called calculate vertices, so we can have our steps. Before we can calculate our vertices, though, we need to calculate the steps between each vertex. So I'm going to say here, calculate steps for each or calculate steps. So we have two steps that we have to calculate here. So it's width step and depth step. So for width step, all we have to do is take the width that we've set here and divide it by WP. Then our depth step is going to be our depth, and it's going to be divided by DP. And that's pretty much it. So we're saying how big is our cloth in terms of width and in terms of depth, and what is the delta between each of these, or how, like, yeah, basically what is, how much do we want to split it, on how many steps do we want to split it, and then from that we get the step, which is the delta. Okay, then the other thing that we need is, because we want to add texture coordinates, we also have to calculate those. So we're going to say calculate the steps for text coords. And if you remember with texture coordinates, basically before we divided the width and the depth into steps, now what we have to do is divide 1 into steps, because our texture coordinates will go up to 1. So we're going to say du is going to be 1.0f over how many vertices we have. So it's going to be grid res minus 1. Then dv is going to be 1.0f over grid res minus 1. Okay, so that's it for the steps. Now we can go to calculating our actual vertices. So we want to build the grid, and we want our height is going to be the same everywhere, so our y is going to be init height, which is right here. So we need to calculate x and z. So, well, let's think about this. We obviously need a for statement, and because we are calculating based, well, we need depth and we need width. Let's say we need a float here, because these are going to be floats, d. And I'm going to say that I'm going to always start from, you can start from another position, but I'm always going to start, because it's easier, from 0 for the depth and move, basically. And the same is going to be done for the width as well. So we're going to start from the 0 position and move on. So I'm going to start from 0. So I'm going to say float d. And then d is going to be changed based on our depth step, right? We calculate our depth step, so d is going to be changed based on that. We do need another variable, though, because we're not going to stop based on the depth here. We're going to stop, because I think it's a little better, we're going to stop based on the grid resolution. So we need the variable up here that is going to be unsigned int di, so depth index. It's going to be starting from 0. And basically, our check to finish our for statement is going to be if di is smaller than grid res. Then we keep going. Otherwise, we exit. And we're going to update d the way we talked about. So it's d plus equals delta time. Delta time. Depth step. And we also need to increment di every single loop. So we're going to have di plus plus. Okay, that's our depth. We do need to do a similar thing for our width as well, right? So we're going to have here for float w, which is going to be our width, which again starts from 0. And it's going to be here. So obviously the same thing that we did before. We had a d index, so depth index. We need a width index as well. So we want to stop when we're done placing vertices on this depth on the width. So we're going to have a signed int dw starts from 0. And same thing, dw is going to be smaller than grid res, and that's when we stop, when we're larger or equal to it. And so now W will be plus equals the width step, and then we also need to increment our DW. And now we can actually start building those simple vertex structs here and placing them in this vector that's called vertices. So the first thing that we know is, well, let's start building. We need a vec3. That's going to be, let's say, temp vertex. So we need to first set these up. And we know that temp vertex dot y is always going to be init height. So we're done with the height. And then we know that temp vertex dot x is very simply going to be the width. So the W that we have here. And then temp vertex dot z is just going to be our depth. So it's going to be d. And it really is as simple as that. Now, we can build a new simple vertex called SV, because why not? And use a constructor, pass the vertex for the position, which is the temp vertex. And finally, we do need to pass the texture coordinates. So we haven't calculated the texture coordinates yet. So how do we calculate the texture coordinates? Well, we'll start outside of this for loop, and we'll go here. And the first thing that we have to do is we are going to set a float v that's going to be equal to di. So the di, remember, is our increment, so which vertex we're on. And it's going to be di times dv, which is our delta that we calculated here. And that's for, so this is depth, this is going to be v. For u, we're doing a very similar thing. So we're going to go after these position vertices for positions and say float u is wi, so our increment for the width times the delta for the u. So that's how we calculate this. I called it dw. I want it to be wi because it's better. Okay, so now we have u and v as well. So all we have to do is go here and say glm vec2 u point v, or u comma v. So we've constructed our simple vertex. Now we can actually place it into our vertices vector. So we're going to say pushback and say sv, and we're done. Is there something it doesn't like? Oh, there's a comma here. Okay. And this one is di, or wi. We figured it out. Okay, so now we've constructed our vertex and we've stored it into this vertices vector. Okay, great. So if you imagine how this works, it literally builds a grid of vertices based on the deltas that we calculated here. So that's the steps between each vertex. And it's going to have a grid res of this, both on the width and both on the depth. And the height is always going to be the same. Now that's great, but we do want to render triangles. So we need to find out what our indices are. So two things. We need to find out what our quads are. So what represents a quad, so we can split it into triangles. And then figure out the triangles themselves. So we need the indices that represent quads. So 4 vertices, each of which represent a quad. And then those 4 vertices will be split into 2 triangles each, because we want to render triangles and not quads. So first, we're going to calculate those indices. And I'm going to say calculate, let's say quad indices. And we have to store them somewhere. So I'm going to go here, and I'm going to say standard vector. And this one is just going to be very, very simply, we can just store unsigned ints. So, because they're indices. So unsigned int, and I'm going to call it indices. And after for rendering, we're going to have one more of those. That's going to be the tri indices, which is going to be for the triangles. So let's start with the calculate quad indices. To do this, we need to understand which vertices represent a quad. So I've created a little thing here in good old Paint, because it's easy. So if we have a good resolution of 3, so we have vertices 0, 1, 2, 3, 4, 5, 6, 7, 8, because that's how we created them, then this is a quad, and this is a quad, and this is a quad, and this is a quad. And each of these will be split into triangles. So first we need to find out the quads. So this first quad is going to be vertices 0, 1, and then it's this one. So it's 0, 1, 2, 3, 4. So it's 0, 1, 4, and then it's 3. So we can use this pattern to actually find the indices that represent the quads. So basically, so we need a for statement. Let's start with a for statement. Let's say I have a size t, I, that starts from 0. Okay. And obviously this I will have to run on the whole size of the grid, which very obviously is a grid res -1 times, believe it or not, grid res -1, right? And then I can say I++. So that's a very simple for statement. So again, we want to be adding 4 indices per step here, right? Because we need 4 vertices to represent a quad. So every single time this loop runs, we add a quad. But how exactly do we do that? Let's start with the first quad. So let's say indices.pushback. Well, the first quad would be 0. And I know I'm hard coding these now, but I'm going to change them, don't worry. Then the second quad is going to be the one that's right next to it. So it's going to be 0 + 1. Then the next one is the one that's underneath this vertex. So it's 0, because that's where we started from, plus the grid resolution, right? So if we go back, we can see that to get this one, all we have to do is start from the first vertex of the quad and add the grid resolution, which is 3. So it's 0, 1, 2, 3, and then add 1 to it. So we're going to add the grid resolution and then add 1. And obviously, as you just saw, the other one is going to be 0 plus the grid resolution, like without this 1 here. And this will be each quad. So this is a very good pattern that we can follow. The one thing that changes in this pattern is this 0. So I can call this index start and keep it as a variable. And let's set this here, and it's going to be an unsigned int, so index start, and it's going to start from 0. So now I have to figure out exactly how I increment this. So how do I change this? How do I update this? Obviously, when we're in the first quad, the index has to be index plus 1, right? So if we're here, then we go here. So we start from this one and we get this vertex, this one, and this one. Okay. So it's very self-explanatory that all we have to do is do this plus plus in the end of every loop. However, there's a problem with this. When we are here and we're done with this quad and we go down here and say index start plus plus, we're going to end up starting from here. But there is no quad here. And obviously we don't want to start a quad from this final column of this grid. We want to go down here and get this grid, this cell, so this quad, and then this quad. So when we're at the end of the width here, what we want to do is we want to do a plus 1 before we get to this quad. So if we are done with this quad, and then we're done with this quad, and then this plus plus leaves us here, we want to get down here. So all we have to do is increment index start before we get to this next quad. So here, I have to figure out when to increment this. And it's always going to be incremented by 1. But when do I increment it? So I'm going to say if, well, it's quite obvious that I incremented when I'm at the end, right, of each of these rows. So I'm in the final column, so I can just say I, modulo operator, grid res minus 1 equals 0. And then I can say index, is it going to find? No. Index, I can't type. Index start plus plus. However, there's a small problem with this statement. So obviously if we're here, so this is 0, 1, 2, so when we're at 2, and the grid is, res is a 3, so grid res minus 1 is a 2, so we have a 0 here, so we would have an increment, we would increment index start, we would actually be where we want to be. However, if you calculate this, for 0, you will notice that this will actually be true. So when I starts from 0, it's going to be incremented, and we're going to go here, and we're going to miss this quad. So we have to say when I is not 0, and this, we index start. So we skip it basically the first time, but then every single other time, this should work just fine. And that's it. That's how we add our quads. So now our indices vector contains the indices so for our quads. So we have sets of 4 indices in a series, each set of which represent a quad. Okay, so we have our quads, but we are not rendering quads, and we don't want to render quads. So let's say here calculate triangle indices. So we said now that we have our quads from our grid, and now because we have our quads from our grid, we can split it into 2 triangles. So each quad will be 2 triangles. So we're gonna have a for statement. So you probably figure out how this is done because it's pretty easy. So just starting from 0, and we're gonna go through all of these indices that we just found for our quads. So we're just going to go through the whole vector. So, but this one is not going to be I++, it's going to be I plus equals 4, because like we said, each 4 represent a quad. So it's going to be plus equals 4. So this is our for statement. So again, we want to add 2 triangles each time this thing runs, right? So each time this thing runs, we're processing a quad. So we want to have 2 triangles for each loop. So basically we need to add 6 indices the try indices vector each loop, right? 3 for the first triangle and 3 for the second. If we go back here, because we're using the clockwise form, you're going to notice that we want to start, if we have this quad, the first one, we're going to start from 0, and then we're going to go to 1, and then we're going to go to this one. And then we're going to go here, here, and here. So we have this triangle, we have this triangle. Okay. So quite obviously, to get that, we're going to say try indices, push back, and we're going to go to indices, and we're going to get the first one of this loop, so I, right? Because that's the start of our quad. Then I'm going to copy paste this twice, so this is the first triangle. The next one is the vertex next to it on the quad. So we're going to say I plus 1. And then the next one is the vertex that's underneath, right? So it's this vertex, which again, we added immediately after. Our quad is this, 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 and this. So it's the immediate, immediately next vertex. So we're adding I plus 1, and I plus 2. And that's the first triangle. So now we have to find out what the second triangle is. The second triangle starts from the same vertex. So from this one, so I, and then it goes down to here, and then it goes down to here. So this is going to be I. The second vertex is going to be I plus 2. And the one here is going to be the last vertex that we added in the quad, so I plus 3. And that's it. This will give us the vertices, the indices that we need to properly render our mesh. Good. So now that we've done this work, let's set up the buffers for the rendering. So we need a vertex array, so we can just use GLGen vertex arrays. Obviously, this is not really the most important part of the tutorial, but you know. So we generate a vertex array, and we store it at VAO, and then we need to have a buffer. So we have a VBO, and we have an EBO that we generate. All of which are stored again here. Okay, so we've generated our buffers that we need. And let's start with our vertex array. So first we need to bind it. So we're going to say bind. So bind vertex array, VAO, and then bind our buffer. So GL array buffer, which is our VBO. Okay. I'm going to do this here. And then we need to pass the buffer data. So it's going to be GL buffer data. And this is going to be, again, we're passing to the array buffer. And remember what we want to pass is, so it's the size. So we have vertices first. This is where we kept our vertices. So the size of, so how many vertices we have, times the size of this. So we can use size of simple vertex. Then we have our vertices, which is, so there are many ways to do this with a vector. I think you can pass we can obviously pass a pointer to the address to the first element of a vector, but you can also do this, which I like more. So you can say vector.vertices.data, and it will give you the address that you need here, so the pointer. And then we're going to say GL dynamic draw, because we're going to be updating the vertices quite a bit because we're simulating them, right? So they're not going to be the same positions. Cool. So now let's set up our attributes here. So first we have our vertex positions. So we have GL vertex attrib pointer. So 0, 3, because we have obviously 3 floats, GL float, and I'm going to say false here. And the size obviously is going to be simple vertex. And here we're going to pass void 0. Okay. And then we're going to say GL enable, obviously, vertex attribute. Oh, vertex. I hate this command. I hate it so much. Attrib array 0. Then we have our vertex text coordinates, which is going to be very similar. So we're going to say GL vertex attrib pointer, and this one is going to be at 1. We just have 2 floats here, so 2 flat floats, GL false, and again the size of symbol vertex. And then obviously we need an offset. And so we're going to say void pointer here. And we're going to say offset auth, which is a very nice and convenient function. Simple vertex. And we just pass text coordinates. Not text file, text coords. Excellent. And we also need to enable the vertex attrib array, attrib 1. Okay, so now we can unbind this. So we can say GL bind buffer. Set this to, well, obviously GL array. And set that to 0 to unbind it. And let's unbind the vertex array as well. So again, just set this to 0. Perfect. So these are, so we have our vertex positions, coordinates. So we passed our vertices, but I forgot here to obviously add our EBO because we need to pass our indices as well. So here I'm going to say GL bind buffer, and I'm going to say GL element array buffer. Hopefully. There it is. And that's going to be our EBO. So bind it. And then all we have to do is GL buffer data. And this one is going to be our GL element array buffer. And the size is going to be try indices. Again, we're passing our triangle indices. We're not passing our quad indices. So it's going to be try indices, size, so how many we have, times, we can say size of unsigned int, because that's what it contains. Then we're going to say try indices dot data, like we did before, to get the pointer. And we're going to use, again, GL dynamic draw. Excellent. So now we passed our vertices, or we passed our triangle indices. So we have everything that we need to render this. You won't have to concern yourselves with shaders at all, because they're all done, and I don't think that's very important. It's not like you're doing anything crazy with the shaders to render this. Okay, so we have the basic things that we need for rendering. We're going to need more things for the simulation, but we may as well end this video by just rendering this and see whether it works. So I'm going to go under the constructor, and I'm going to call a render function. So I'm going to make a render function. It's going to be void render, and a render is going to take a shader, which I've already created as a class somewhere, And it's also going to take a model matrix in case we want to move it around. So I'm going to call it model here. So cool. I'm going to say shader dot use first. So ignore all of these things because you might have, they're not part of the tutorial. And I'm going to set the matrix here, my model matrix. And so there's a lot of GUI stuff that I've already set up. So you can actually start the simulation, do all of that stuff, slow it down, move it around. So we're going to be adding all of these things on this cloth mesh HPP, but they're already implemented in terms of GUI, so you won't have to do anything else. So the first thing we have to do is bind the texture. And yes, I know we didn't load any textures. We're going to do this before we render it, don't worry. So we're going to say GL texture 2D. And we're going to say texture ID. So bind the texture. And very importantly, I'm going to disable GL cull face because I want to render it. Keep in mind, we have no height here. So we have a flat plane that would only, the way I've set it up, it would only be renderable from the top. So, but we also want to see it from the other side as well. So we're going to disable culling for this. Then we can bind our vertices. So our vertex array, which is a VAO. And now we can actually render. So we're going to use draw elements because we're using indices. And we're going to draw triangles, which is the only thing you should be drawing. And we're going to pass our indices dot size and say unsigned int. Oh God. Unsigned int 0 here. And that should render our cloth. I'm also obviously going to go here and unbind the vertex array because it's good practice. And I'm also going to enable culling again to make sure that I don't have to do this somewhere else. Perfect. So we disable culling, we load a lot of stuff, disable culling, render, enable culling again. Perfect. So before this, because I'm loading a texture and it's better to look at it with a texture, let's go and load a texture. And we said that the best place to do this is to do it on top here on our constructor. Because remember, we have a texture file string that we pass here. So let's do that because it's easy. So the way I like to load textures, so let's say load texture here. Keep everything nice and tidy. So I want to load the texture from a specific folder. And to find that folder, I can use this method where I can get a buffer of a specific size, which I'm going to say is 1024. And then I can use get current working directory and write to the buffer and basically get where I am. And this makes it nice and portable. So I know now where I am in, so no matter where I've not installed, but where I've stored my source code and everything. And based on where my executable is, I'll find out based on the get current working directory. And now I can just say standard string texture. I'm going to call it texture path. And I can pass the buffer to initialize this, to set this texture path. And then I can go to texture path. So now I know where I am, like where the executable is. And if you look at how this is set up, what you have to do to get to the textures folder, because there is a textures folder, is do this. So go back once, go to textures. So do it like that. And then to this, we can add our texture file, which is the name. So this brings us to the folder. So this part brings us to the folder. And this brings us to the actual texture file that we want. Excellent. And then obviously we have to load the texture. So we're going to say texture ID, texture from file. And all we have to do is pass our texture path as a C string and false for the gamma because we're not going to use it. Perfect. So now we're loading everything. We have set up everything here. I think we're ready to test it. So to test it, we can go to our main CPP, and I'm going to go all the way down here before the rendering loop. Let's say after I see the RNGs. And I'm going to say cloth mesh. And I'm going to say cloth mesh. I've already included the HPP on top, so don't worry about doing that. So I'm going to call it cloth. And I'm going to set some variable values here. I'm going to say 5.0, 5.0f, 8, 16, and I have a texture called cloth fabric.png in the textures folder. You can put any texture you want there, by the way, and just add the name here. And that's it. So that should create our cloth. Also, before we finish this, let's add a line here that kind of tells us what kind of cloth we created, because why not? So I'm going to say standard cout created cloth mesh with, and I'm going to say vertices.size, so we should know how many vertices we created it with. That's in total. Vertices, and I also want to know the indices. So try for the triangles. Size. Say indices, and then standard and line. Excellent. So we're going to get a bit more information when we render where it created. So I'm going to put a breakpoint here, and I'm going to debug, and I'm going to hit run and see whether this works or not. Obviously, it has to kind of build everything because I did what you would do. So I actually created a new solution. And you can get rid of the GitHub stuff and the Git stuff you do want to, because ideally you should have your own little Git repository to add these to if you want to track your progress. So now we wait, because this is a renderer that I used for other things as well. So it has a lot of things that we don't actually use in this tutorial, but why not? We might as well keep it. Okay, so now it's doing our stuff. Okay, I think it went through the cloth mesh, so that's good. Oh. Oh, yes. You need to go here and hit, so to cloth sim toot, and hit set as startup project, and now it's going to be working just fine. Okay, so our build went well, and we can go to here. We can go to our console and say create a cloth mesh with 256 vertices and 1350 indices. Great, so let's continue. So we created our cloth mesh. Let's now render it. One thing I'm going to do is, so that you can see here, there's some shadow stuff, so shadow maps. What I want you to do is I want you to delete this line and uncomment these lines so you can get a nice shadow from our cloth. Good. And make sure that it is actually called cloth so you can actually reference it here. And here, we can actually render the cloth, which I forgot to do. So I will do it under, where should we do it? Here. So we're going to use the custom model shader, which I've set up. And I'm going to say here, render cloth. And let's just render it for now. So we're going to say cloth dot render. And remember, we have to pass a shader. So we're going to pass our custom model shader, which we've used before and set up our projection of U matrices. And here we just pass our model matrix. I'm just going to pass for now mmat4 1.0f. So no change should be made. Okay, so let's run it. And look, we have a cloth. So it works. So you can see what it looks like. And if you hit here, toggle wireframe, you'll see that we build it from position 0, and we started off with our quads here. So each of these are a quad, and then we have 2 triangles per quad. So our strategy worked perfectly fine. Obviously, hitting play doesn't do anything right now. Great. Congrats, now you have rendered a cloth that you completely custom wrote as well. So in the next video, we're going to move on to some basic simulation stuff and see exactly what else we need to run the simulation. Hope to see you then.